Hello everyone, welcome to another one of the very few non-game related videos on my channel. What I wanted to talk about today is a project I've been working on for the last couple of weeks. I have a pretty horrible track record when it comes to actually completing my projects, so I figured I had to make a video about it to force myself to finish it. As you probably saw by the title, I made a desktop pet, but not just any desktop pet, an AI-powered desktop pet. Why exactly? Well, why not? AI is in pretty much everything these days and is single-handedly getting a lot of my friends through school, which is somewhat alarming. So I figured what's one more little AI tailored to do basically nothing but be wrong and be cute. And because I have no more backstory to give, let's explore how I made this little guy. So obviously the first thing I did was make the AI portion. I won't get into the specifics because all it really is the AI coded in the book, build a large language model from scratch. But what I will mention is how I went about training it, because it was painful. I'll start with before the first line of code was even written. I just recently upgraded from that insanely loud laptop I talked about in a previous video, and finally built my first PC. It's a pretty good build, and it was definitely worth the years of saving up for it. But do you see the problem here? I'll give you a hint. It's the Radeon logo right there. That, my friends, is a 9070 XT. Great for gaming and game development, which is what I normally use it for, but not so much with AI, because it doesn't have CUDA. Now, PyTorch, the library that handles a lot of the math for the AI, does have a CPU-only version, and that runs okay, but it takes a few hours. But it turns out that you can use ROCm, AMD's CUDA equivalent, if you run PyTorch on WSL or Windows Subsystem for Linux. So it was easy enough to get that installed on my system. After all, it's a single command. But what I wasn't expecting was the sheer pain of trying to install pretty much anything else. I don't know if it was specifically because I had pip already on my system in the Windows part, but it just kept being flagged as an external command. So after 5 hours of scouring 9-year-old Reddit posts, I was finally able to begin development. And off I went, using the book and Copilot to help me fix my typos. I had a working GPT in about 3 days of on and off programming, then I loaded the weights that OpenAI published when they released GPT-2, and I had a coherent GPT to work with. Then came the fine-tuning step, because I'm trying to make this into a chatbot. I'm not quite sure what I did wrong, but my AI is way more wild than the one in the book was. Let's look at a few of its responses, all using the training dataset the book provided. So apparently Japanese cuisine is the capital of Japan. The prompt was, tell me something interesting about pandas, and the AI said, I have told you 1,000,000 times, exactly 18 times. According to the AI, some common methods of data analysis are apples, bananas, oranges, mangoes, and gathers. The response to a query about the history of capital punishment was that the death of St. Kennedy is considered to be a major factor in the Civil War. Another prompt was asking about different political sides' perspective on the death penalty, and the AI just started shilling for Linux. It turns out climate change is a system to set the average temperature of the Earth to Celsius, while an effective strategy to conserve energy in the home is to implement a solar-neutral diet. When asked to rewrite the sentence, the students completed their assignment soon, to emphasize the word quickly. The AI just said, quickly. And a final fun fact is that a skunk cabbage is a type of animal that is typically used to create documents. And believe it or not, those are some of the less ridiculous ones. For some reason, the only ones it's good at are explaining why it needs to exist, and apparently it will shill for Linux at just about any opportunity. Given these results, I then tried to train it on the Alpaca dataset, which is another pretty common one, and I think this is a pretty good example of how that went. So for the time being, I'm using the utterly insane version. And now for the fun part, putting this thing on screen in a presentable fashion. The first thing I did was port the files over to Windows, because I wouldn't need the AI acceleration anymore. And then I fought with my PC again to install Pygame and Pywin32. The last one is the easiest to explain, so I'll do that first. So I want this to be able to be on my screen, but still be able to interact with everything behind it. And with Pi-Win32, I can make the window transparent by chroma keying out a specific color. And then that allows you to click behind everything. And now to explain why I'm using Pygame. I'll be honest and say that I would rather be using literally anything else because I hate Pygame. I like Godot for basically anything else that I can use it for. But it was the only thing that I knew for a fact would work simply because it's written in Python. Now, obviously, I have some experience with Pygame. Those little video game clips I posted a while back were the Godot version of something I originally made in Pygame. And even though I abandoned both forms of that project forever ago to release a better game, I still needed to refer back to the Pygame version to figure out how Pygame works. Because frankly, the Pygame documentation is not that good. So now let's start talking about features. The first thing I did was break the model into about 4 or 5 helper functions that each did a specific thing. The first one tries to detect what device you're going to run the model on. So with my computer, if I was in Linux, this is my GPU, otherwise CPU. For an NVIDIA GPU, it's always the GPU. And on a Mac, sometimes they have Apple Silicon that can run AI. The second function just creates the GPT-2 tokenizer using TickToken and returns it, which is simple enough. The third creates an instance of the model, loads the GPT-2 weights into it, loads any training checkpoint I have onto it, puts it into evaluation mode, sends it to the device being used, and returns the model and the optimizer as a variable that can be used in the main script. The last one takes a prompt from whoever's talking to the model, uses another function to generate the response, cleans that response, and then returns a clean text. The text needs to be cleaned up because the fine-tuning process caused the model to repeat its instruction before it gives its answer, and cleaning it gives basically only the answer. So then once the model was set up in that way, I imported it as a module, instantiated it, and tested it, and thankfully it worked. Then, because I usually work with 2 monitors, and one would be basically completely obstructed by the pet, I used tkinter to create a pop-up before the main Pygame window that tells you to select which monitor you want to have the pet on if you have more than one. While doing this, I actually learned that apparently you can have function definitions within function definitions in Python, which I thought was kind of strange, but it made everything a lot easier. Then I made the main Pygame window fill in with this really ugly pink and chroma keyed that out, which would turn the window transparent. Most of the footage I have from making this has this pink still in it because of OBS, but trust me, it's actually clear. And with those critical things done, I started to think about what I wanted to do with the pet. Obviously, I wanted to be able to talk to it, but I think it would be boring if you could only do that with it. So I thought, what if you could give it a treat just like basically any other pet? And with that, I added 3 buttons, one to start talking to the AI, one to stop talking to the AI, and one to feed it. It was also at this point that I gave it a kill switch because the Pygame window is only closable from the taskbar otherwise. Once the buttons were there, I made them clickable. But then with all that progress being made, I forced myself to deal with by far my least favorite part of Pygame, which is the sprite class. When I made that little space shooter thing a month into learning how to code, I spent days trying to figure out how to get these to work in the game loop. But I proceeded on to make a cookie class somewhat harmlessly. It even has gravity. The bounces took some time to figure out though. Because at first it was going into the stratosphere, then it wasn't hitting where I wanted it to, but I finally got it to work. Then the final thing I needed to do was put the AI on screen. So I started by making another sprite-based class called AI Pet, gave it the model and resolution as parameters, established the model within the class, and made it a giant green rectangle stapled to the bottom right corner. Once I saw that it was properly on screen, I started coding the way to take player input. The solution I came up with was to make an empty string at the start of the program, add a boolean for when to listen to input, and just append everything but the kill switch, enter, and backspace to this as the keys were pressed. Backspace grabs everything but the last character of the string, so it looks like things are getting deleted. The input string is then displayed when input is being accepted. Pressing enter calls the AI pet's internal talk function, which passes the input string into it and returns the cleaned up response. Putting the response on screen was a little bit more complicated. In the same vein as the input, I made another empty string at the beginning of the program. When the input is submitted, the returned value replaces this empty string, and the string is displayed on screen. But you'll notice that the model tends to respond with much longer strings than can be displayed in one line. Instead of taking the actual solution and forcing multiple lines to be displayed, I decided to add another button. If the response is longer than the number of characters a 1080p screen can display with the 40-point font, which is what is being used here, a button pops up, and when that button is clicked, a tkinter window pops up showing the entire output. The input and output can only be cleared once this window has been closed, because closing the window is required to complete the piece of code that opens it. So that's all the AI-related code, but what use is it if there's nothing to look at? So I gave the AI pet class an animate function. The first thing I did was implement collision between the mouse and the pet's rectangle so you can kind of pet it. Then I timed the number of frames the pet stays in its eating state after collision with a cookie, and at 60 FPS this is about 197 frames. I know I could have gone for the standard 24 FPS and spent the time saved doing the math to get it to look good, but I instead animated at 60 FPS because I thought it was a nice challenge. I haven't done non-pixel art animation in like a year. The character I went with is this shark-like thing, because most of my desktop backgrounds are Subnautica landscapes and space. And that's also the one thing I know I can draw really well. So the eating animation is it chewing and then closing its eyes and smiling. The petting animation is it wagging its tail. And the idle animation is it licking its eye and wagging its tail. Look, I have a lizard and 2 dogs. This is what pets are like for me. Once I set up the frames, the pet is done, and later I went ahead and made it so that hitting the other thing on the tilde key hides everything but the drawing, just to make it more usable. And that's pretty much it. At some point I would like to tinker with the AI and train it on a different dataset with the same format to get some better results. Maybe one day I'll figure out how to make it talk with text-to-speech, but for now it's enough. I also need to work on the chroma key, but it's still not bad for doing something in 1 week. Normally this is the part where I would say goodbye, but I think I'll let the pad do it for me.